Everyone. I'm just getting set up right now. Give me a sec or two. Grab this. It's here. Probably should have set this up before the stream, but oh well. Let's see. Make sure everything's live. It does seem to be. Okay. Cool. Yep, okay. Sharing the right screen. Okay, so today, I guess I want to do a little something. I had this thought on my mind for a while. I'll draw it out for you so you understand it a little better. My thought was, let's say you had an RL agent. So you had some agent, and its job was to generate random numbers. Or random seeming numbers. Random numbers. Well, one, is this possible? I think so. I think I guess, the reward would be a bunch of different statistics saying whether or not the sequence the agent is generating is random or not. So you could say chi squared error. So chi squared. So this is just a method to say whether or not your sequence is random or not and measure how random it looks. So in my mind, you could have an agent, it generates a number, the reward is based on chi squared, and you basically feed this loop back into the agent and eventually it'll learn. So from this idea, I was like, okay, let's say I wanted to add a small bias. So let's say we were having a heads or tails game, so, this is heads, this is tails, so heads, you win, tails, I win. Yeah. So, is it possible to train an agent where it will generate, so it's going to try to generate heads or tails, but instead of just getting the chi squared returned back to see, how normally distributed these things are, it would be the p-value plus the chi squared. And the p-value basically, oh wait, no. Be p-value instead of chi squared, so we wouldn't need chi squared. Say the p-value, so basically how the p-value works is the higher the p-value is, the more likely that it is random. So anything above 0.05 you would assume is random. And plus, let's say, money. So let's say you could bet from $0 to $50, and if you bet $5 and it's let me do heads, you win, tails, you lose. So if you bet $10, you win $10. If you bet, and it's heads. If you bet $20 and it's tails, you lose $20. So my thought process here is that basically we could, I don't see why, at least an online casino, maybe a regular casino, can't do this. Have this little agent here that looks at every single hand dealt and make sure all the I'm assuming there's just a bunch of statistical tests, probably more than just chi squared. It's probably a bunch. But the whole premise is have an agent trained on trying to make it look as random as possible and actually be random according to these tests while generating a little extra money. My assumption is that casinos don't test for, I guess, the bet amount. They're only testing for the probabilities. I could be wrong there. I don't actually know the inner workings. Yeah, so from here, I basically, did this break? No, okay. I wrote up some code that does some, it's basically a basic RL agent that does this. I can, let me zoom in on my screen. Not gonna walk through all of it. The basic reward function. So we're looking at three different p-value generators, or three different p-values, and each one has a different, we're generating it slightly different, so this is for the autocorrelation. Won't go into all the details of it, but basically we made the reward where it's looking at the p-value, and then it's looking at the bet reward. So this is how much money it actually made. We took, we made the, what is this? This is the how well random it looks. We gave it a little extra bump, and we actually, the beta is I think 0.004. Yeah, so this is just to make the bet reward a little less, and because we want to say, like, fairness, you want to always come off fair, because once you come off unfair, that's a big issue. So I trained this for, let's see, 2,000 episodes. And that's, you could see here, and you can see the reward, generally solid. You can see, like, it's here generated 158 times and won $258. I mean, right now the reward, I mean, it should be winning $0. It's just theoretically a fair game, meaning there's, in the long run, everyone should win equal amount of times. I should win, and you should win, or the house should win, and the player should win equal amount of times, because it's 50-50 on the probability. Let's see. So, yeah, so we basically, again, just to repeat myself a little, we have the agent, it tries to predict heads or tails, or tries to generate heads or tails. Gives, the reward is basically a p-value if it's just seeming like a random sequence, and the money that it won. So here's a little, I guess, game that you could theoretically play where basically, let's run it. How much do you want to bet? So let's say I was assuming I thought this was a fair game. I thought this was a fair coin or whatever. I don't know. Let's say I bet $25. Oh no, I lost 25. So I'm down $25. So now maybe I'm a little scared. I'll bet $10. Oh hey, I won $10. Nice. Feeling good. Let's go back up to 50. Oh, damn, I lost 50. Okay, but I can't lose 50 again. It's heads or tails. Okay, I won that one. Anyone in chat have any wants to play a hand? Just say 0 or 1. If not, I'll keep playing. But I mean, as you see, like this, I say 30. Okay, hey, I won $30. I'm actually up some money. Maybe I'm feeling extra good. I'll go $50 then. And I lost $50. Let's see if I keep playing. So I want to bet 50 again. I'm down 85. So maybe I'm getting a little scared. I bet 20. Oh, I'm down 20. I can't lose again. $50. Okay, that time I won. But basically, in my mind, I don't see why. Let me stop this. I don't see why a casino won't be able to do this. Because instead of heads or tails, they'll do, let's say, blackjack. And it will be able to choose every single number that will come out, or every single card that will come out. It will produce these cards also while keeping track of, the p-value, the chi-square test, whatever. A bunch of statistical tests saying whether or not it's cheating, and I'm guessing and then you just train this RL agent to maximize money while not getting caught. And the numbers seem like, let's see, numbers seem random. I mean, they seem pretty random to me, but also they seem pretty random to the chi-square test, and, the p-value is, extremely high and so on. Actually, chi-square test is relatively low. So it actually might have gotten caught here. But we could theoretically train this for a longer period of time. and I'm sure eventually it will converge to a better output than what we have right now. Um, yeah, I mean, this was my main rant I had. I just don't understand how a casino. I mean, maybe they audit them when they look at their code and they make sure they're using, numpy.rand or whatever, and then it's fine. But if they're not looking at the direct code, then they probably could just train an RL agent. And I guess in my mind, like, now that I know, this is trying to cheat me a little, I could probably, let me bet the minimum. Okay, hey, I lost $1. Okay, cool. Let me bet the minimum again. Oh, I won $1. I could keep track of my winnings and losses. So now I know, hey, so let me go $5 because I just lost. Oh, now I up $4. But now I'll probably be scared again. I'll go $1 again. I lost $1. That's $1 again. I lost another dollar. So now I know it's gonna have to make up for this, and it's not just random. It actually is planning. So I could say, okay, you drew one twice. I don't. Okay, now I won $20. So now that I know this is how the system works, I probably could try to game it a little. It'd probably be a little more interested in a casino because they probably look at every single table and every single hand and do this method. And it would be, so it's not just you betting, like right now it's just me betting, but there's actually like 100 other people betting or 1,000 or a million other people betting if it's online. So now I won, so let me go $1. So now I lost, do another dollar. I'm not feeling so lucky. Oh, I would have won that dollar. Go another dollar. Lost another. Okay, so now it seems like. I mean, you could keep. I mean, oh, so now I lost my 20, but now I could bet 50. Now I lost 50. And this is how I get deep in the hole. Okay, now I'm broke even again. Now I'm up $50. I mean, just knowing that like it has to make like it's going to try and make up and keep the chi-square score equal, or to basically show it's not cheating. Um, yeah. Um, so I guess I mean, so now I want to learn. I mean, this is my motivation for wanting to learn a little more about RL in general. I mean, not my only motivation. I also think it's relatively cool. But I don't know. This is crazy to me, just because I'm just thinking like I don't know how this wouldn't like if I was. I mean, also this is just looking like I'm not even giving it the chi-squared values. I'm just saying, hey, your input is just the sequence basically, and it gets rewards and stuff based on that. But if it could also theoretically look at the statistical tests and learn from those, and I'm assuming this would get a lot better, a lot faster. Um, I don't know. Interesting. I mean, to me, it's interesting. I don't know if anyone else will find this as interesting. Um, so now let's say I wanted to learn RL, at least RL more in depth, because right now it's relatively simple. Uh, there's a classic reinforcement learning book, this, and it's also free online. So I'm probably going to walk through this unless anyone has any questions about, I guess. Or if anyone sees any flaws with my logic, please let me know because right now it's driving me crazy. I'm just like, why wouldn't a casino do this? It's seemingly random. Again, if someone knows like, oh hey, casinos actually have to show their code and have the code reviewed by a third party, fine. I'm good with that. That makes sense. Cool, they can't do this. But if they're just looking at the probability outputs, I don't see why. And they have a set of tests. I don't understand why they can't do the system and just make a bigger set of tests and just have an RL agent producing things that seem random. And then I feel like a lot of people will give the argument of like the casino's already making, they already have an edge. Why would they do this? Why take that extra risk? I mean, you could there's billion-dollar companies still committing fraud and because growth and they want to make more money. I mean, it's not so such a crazy concept of like, oh, why would someone do something bad? I don't know. They want to make more money, and they don't think they'll get caught, or I don't even know. Maybe this is fine because all the statistical tests are, passing. I mean, also, I guess if you look at, they should be able to compute. Like, if you want to fix this issue, and I don't even know if it's an issue, you'd probably the auditor should probably also look at how much um, money they make. Like, if it's a $50 hand, or yeah, just if I'm playing blackjack and there's 48, or can't say there's 48% odds because that's if you're playing a perfect game, your probability of winning as a player is 48%. But people are probably going to play worse or better, and that probably, yeah. You get the average amount that people win in blackjack, and you could assume their profits to a certain degree. I'd say that would be a relatively fair way of computing if a casino is cheating or not. But, okay. Let's get into some RL. So I'm going to try and walk through this book. Problem. Okay. So I'm going to try and walk through this book, but I'm also going to use DeepML or DeepZero to try and help me. I need to sign in. Hold on, I'm going to try and use DeepZero to basically generate questions while I study. So I'll read an armed bandit problem, and then I'll create a question based on an armed bandit. Here we go. Put this back here. Okay. I actually know what an armed bandit is. It's let me read it just to refresh myself. Consider the following learning problem. So we have n different options or actions. After each choice, you will receive a numerical reward chosen by stationary probability distribution. Okay. Okay, so right now we would have a system. Let's simplify it. Let's see, you have two options, so two arms, and you could pick, red or blue, and let's assume with this. I'll explain this in a second. What I'm doing. So this we'll assume is the reward, and you basically need to pick, one or two. If you pick one, you will, basically choose a random reward from this distribution. And was it uniform distributed? Receive a numerical reward chosen centering the probability distribution. Stationary probability distribution. Okay, so you're basically choosing one or two, and there will be some distribution, I guess, of how much reward you will get. And here you also will have some distribution for how much reward you would get. Okay. So we'll assume this is, let's say, 0 reward, and this is 10 reward, and your job, I guess, is to, you don't actually know these distributions beforehand. You just know I can pick one or two, and it's your job to, basically choose which action you want to take to get the most reward. So, I wonder if okay, so let's try So we just wanted to start this off. Let's understand what an n-armed bandit is. Generate. I wonder what the most recent questions are on Deep Zero. On eigenvalue and eigenvectors. I wonder if it actually created a good. Yeah, that's not a good question. I mean, it seems like you should just enter a topic and not say generate an like don't say generate a question for me based on this. Just enter a topic. Um, yeah, whenever you enter in something like this, it usually doesn't work out great. I guess while this loads, I hope it actually generates a nice question. We could read up a little more about this. Yeah. Let's see. If you missed the beginning part we were talking about, I mean, I keep on repeating myself, but the motivation behind this is, I feel like a casino could cheat relatively easily. Here is, if you have an agent generating random numbers, and to determine if they're random or not, you basically have a set of chi-square tests and a different set of tests to tell if this set of numbers is random. Here we just did a heads or tails example. And basically the reward is money plus not getting caught. But yeah, let's get back into, okay. So this thing simulated an epsilon greedy algorithm for multi-armed bandit. Let's see, okay, so we could, but I guess, I think it actually mentions, I think it tells us a few different methods, so maybe we'll wait till the end to actually solve this. Let's see, okay. Okay, the original thing, I guess that's why it's called arms, because the slot machine arms. And you're trying to choose, I guess, which slot machine to pick. Okay, interesting. Let's get into this. Action, if I knew the value of each action, that it would trigger, okay, yeah. So it's saying if I knew how much I would get from pulling a lever, this is a very simple question, but I guess the issue is we don't know, so in our minds, we don't know to pick one or two. Let's actually go down to, okay. Action value method, let's learn about this. Okay, we're looking at a simple method. Okay, in this chapter we did okay, so note the true act. So A is the action, QA is the estimated value of the, okay. QA is how much we think we'll make from taking action A. Oh wait, I think this is the actual value, and then capital 1 is the estimated, yeah. Okay, we call it the true value of an action is the mean reward received when the action is selected. A natural way to estimate this is to take the average, okay. Okay, so this is relatively simple, just saying keep a log of all your actions you took and the rewards you got, so. So at time step, let's say this is time steps. At time step 1, you took action. Time step 1, you took action, let's say 2. and you got a reward of 5. And then at time step 2, time step 2, you chose 1, and you got a reward of 3. And I guess you could continue, so let's do this 3, and you said, okay, 2. Here you got a reward of 3 again. And it's basically saying, uh, just keep a rolling average of, so you could say, when I pick 2, it seems like I got rewards 5 plus 3. And it seems for 1, I got reward 3. I mean, you might want to add, I guess, a little length to these things, because if you just start off the bat, they'll just start with, you know, if it first chose 1 and it got a value of 1, 1 is greater than 0 because you don't know 2 yet. So you might want to do something there. I'm sure that they talk about that later, but it's basically saying you basically keep a rolling average and say, okay, so it seems like every time I pick 2, I get, what's that, 8 divided by 2, I get 4. Every time I pick 1, I'm getting 3, so maybe I'll just start picking 2 from now on. Okay, I mean, there's issues here, and we'll probably get into them. But this is the basic, maybe I'll do this for 100 rounds of exploration, and then take the averages and say, like, okay, it seems like 2 is better, so let me just keep on playing 2 forever. And I think that's the basic idea here. Okay, you start them at 0. Okay, the law of large numbers just states things will, the more times you flip a coin, the more closely the heads and tails count will get to 0.5. I'm sure there's a nicer definition of the law of large numbers, but whatever. We call the sample average. Okay. Yeah, we're just taking the average of the values. It's just one of the ways. Okay. Yeah, so now we're gonna, so I guess this was estimating the value of option 1 or 2, and then we're gonna go into how do we select the best action, which I think is relatively straightforward. I mean, it seems like it's what I think it is, just, you're just gonna take whichever one has the higher value. Yeah, so it's saying whichever one has the highest estimate. And this is called greedy action. So I think in our question, epsilon greedy algorithm. So we didn't learn about this, but we're learning, okay, we know what a greedy algorithm is. It's just taking the most advantageous position at time step t. So if you have 2 options, and yeah, I mean, you don't know the future, so it's basically saying you take, if this is options giving you 5, and this option's giving you 4, you will always go with 5, because that's one time step, even if, so the risk is, in the future, there could be -100 and -200, and maybe after the 4, you would have got +1 bajillion or whatever. So I mean, that's the issue with greedy algorithms, but that is what a greedy algorithm is. It just takes, at time step t, it's taking the best choice. So it'd probably go 5, and then it would go -100, because that's better than the alternative of -200. And I'm pretty sure we'll deal with this later. Greedy action selection method, okay. Yeah, so it's saying what a greedy algorithm is. Okay, yeah, my peripheral saw this epsilon, so I'm like, okay, we're getting to probably what greedy epsilon is, or epsilon greedy algorithm is. Okay. So every so often, you basically take the suboptimal route, I guess, just to learn things. Okay, and that would be you just take with equal probability one of the actions versus taking the best action. So it means every so often, let's say you ran this a million times this game, every so often you'd go and pick this route, and you'd probably realize that, oh hey, I'm getting $1,000,000 or whatever this number is. I didn't actually count the number of zeros. So you'd probably start doing that route more. Okay, yeah. This is epsilon greedy. So here, simulate epsilon greedy algorithm for multi-armed bandit. Okay, so let's finish up this section and then try and solve it. Cause method using the... Okay, where was I? Instead of selecting randomly, okay. Cause method near greedy action 2, epsilon greedy method. Okay, it's saying we'll eventually find, this is our estimate and this is the reality, so eventually this will go into this if we use the epsilon greedy method. This, of course, implies that the probability of selecting the optimal action converges to... Okay, 1 minus. So you're saying if it's 1% of the time we do something random, the odds of us, okay, yeah, the odds of us picking the optimal solution is 99% of the time in this, if this is 1%, or this is 0.01. Greedy, okay. So, interesting. So it's saying the average number of rewards for, I guess, I don't know how many arms are in this bandit. 10 arm bandit, okay. Over 2,000 tasks, so it's like this, and we have 10 arms, and we need to figure out which one of these is the best. And they did this, and they found that the average reward for different epsilon values versus greedy seems like being able to explore. Because this probably... how does if this... Like, I wonder if you take the first... Oh, I guess if it's... Okay. My issue was, like, I feel like once you say 1, you'll stay at 1 because you're getting some reward. But this probably starts at 0, and there's probably some negative reward that you could get. And that would make... So if the average becomes negative, you'd probably be like, okay, no longer doing 1, I'll take a different option. Let's get into the actual question, because now I feel like we understand all the words at least in the title. Stretch. Okay. And I write a function that made an arm bandit problem using the epsilon greedy algorithm. Okay. balanced exploration and exploitation based on, okay, so yeah, update incrementally return the total cumulative reward. So our job is to eventually output the reward. Curious if it actually created this question correctly. Let's see. Number of arms. So at least one. Reward for each arm. So I guess we have the true means. So this is, you know, actually how much we're actually making. Does that fit in? Okay, yeah, we're given the true means. Number of steps. Oh, I was gonna say, why don't we just argmax around true means and, you know, we'll just always choose the optimal solution. Well, I guess this question probably won't mark you right because, yeah, you need to use epsilon because it's epsilon greedy. And this is a value between 0 and 1, randomly selected. Oh, okay, oh, that's fed into the, yeah, okay, we get an epsilon value. That's random. And the standard deviation, yeah, okay, so we're given a number of arms, and we're given the true mean, and we're giving the standard deviation. And, okay, and we need to implement epsilon greedy algorithm. Let's see. Okay, let's see an example. So we're fed in, this is 2 arms. These are the true means. What was this value? Number of true means, number of steps, epsilon, and standard deviation. Okay, so number of steps is 10. So it's saying after 10 steps, we were able to get a reward of 20.5, blah, blah, blah. Okay. Minimum function, 2-arm bandit problem, true values, true means of this and this over 10 steps. Okay, yeah, so you have 10% probability, yeah, of basically choosing anything. Okay. Multi-arm bandit problem represents decision-making scenarios where the individual faces multiple options called arms. Chart offers an uncertainty reward. The goal is to maximize the total reward over a series of decisions by choosing which arm to pull at each step. I guess I don't like that. I guess I need to generate the reward because I'm given the mean and the standard deviation. And am I assuming it's normally distributed? Because I'm given true means. Okay, the standard deviation. Do I need to implement my own reward? Goals to maximum. Which arm has an unknown true average reward? Yeah, so it must be bad. Fine, fine, fine. To make information decision, estimate the value of each arm is maintained often denoted as, yeah, okay. So this is our estimate from A. We're trying to compute this. Estimate. Okay, so this looks like a more efficient mean. I'm going to start with a simple implementation. and we'll work from there. Where's full screen? There we go. Zoom in. Okay. Actually, I like starting from the notebook. So we're saying number of arms, true means, number of steps, epsilon. And I'm given. So first I need to decide. Repeat that random. I need to decide to take a. Let me just say what I'm thinking. You need to decide to take the greedy route or the suboptimal route. Just dot rand, okay. And a dot rand. So this will generate a random number from 0 to 1, I'm pretty sure. So if this number is greater than epsilon, so that's 1 minus epsilon. So if it's greater than 1 minus epsilon, just put this in here. So epsilon would be like 0.9, and this would be, okay. So this would mean do the greedy. Else, we're gonna need to explore. Whatever, I can't spell. Okay. So this means this will open it. Yeah, okay, cool. Just take this here. Okay, so this would theoretically be the input in. Oh, let me zoom in. Sorry, be the input into our code. Switch back here. Start writing the function. Add a block above. Okay. So let me just make sure this actually generates numbers from 0 to 1. 0.69, 0.69 again, 0.8, 0.3, fine. Okay, so what does it mean to take the greedy approach, I guess, is the next point, is basically taking, well, I mean, that, I guess, is choosing np.arg max true means choosing this option. So I guess it's action. I don't know if I love this question, because now this might be the optimal decision, but I might not know it at this point. Like I might need to run like we did before, getting the average values and so on. Let me see if it mentions anything about that. Abandoned problem. Pulling arms over a specific number of steps. Balanced exploration and okay. Okay, so if, oh damn, it's late. Yeah, okay. I'm probably gonna have to log off. I wonder if it's this, or, I mean, or do I need to run through each step? And let's see what it, let's see what it was actually trying to say. Saying you have your true means, fine. You start at 0 for all of your estimates, so everything's basically the same. This is the number of arms. Okay. Cumulative reward for each step. Basically taking, yeah, we're doing, okay, they just did the opposite. I did 1 minus epsilon, they just did epsilon. This one you just basically repeat that random int. So this would be your action. You're just basically taking a random one. This is what I'm curious about. Max Q, NVDA max Q. So it's zeros right now, so theoretically this. So we have a list of zeros, and we're choosing, okay. We'll choose basically a random one. Or maybe this chooses the first one, I'm not sure what it does if everything's the same. Okay. Max Q. Oh, okay. Q. And beware it, okay. What is this doing? This is saying anywhere. I'm assuming it's the position. Like which arm had the best position. Best actions. I need to go through this more. I don't like this. This is what I don't like. I need a, I mean, it doesn't tell me to sample from a random distribution, like theoretically. That shouldn't be done in the problem, but it's still, I mean, it's still very good for creating this by itself. Okay. Just wish it told us, I mean, maybe I'm wrong. Maybe it said somewhere, normal distribution. Oh. Okay then, I am wrong. Okay, yeah, okay. I'll take the L. Close that. Let's see. Let me run this. I mean, I know I'm not gonna get any. I'm not gonna get the check mark. I just want to make sure everything's correct. Okay, so it seems to run everything correctly. Let me delete this, and I'll come back to this later. But you know, thank you everyone for joining. I appreciate it. Check out DeepML. Let me know what you guys think. Also, I guess let me know what you guys think about the whole casino RL idea that I had, I guess.